Okay, ladies and gents, we've got in front of us the same data from before, where we've got average if statements calculating the averages of sex, SEN, and free school meal, and then we've got some p-values over here calculated using our t-tests wrapped around and inside an array. Nothing of that is any different. What we want to have a look at, though, is if feeder primary school makes a difference. And we've got feeder primary A, B, C, D, E, and F. Okay. Now F is a catch-all feeder primary where we've got a couple of kids who didn't go to any of the others or who arrived later from outside of the catchment area. So what I want is I want these average if statements as again down here. So this is going to be the mean value. And in here we've got an average if statement, and the range is going to be the feeder primary range. So there's the feeder primary range. My criteria for the first one is that it's A, and then the range of the data that I'm averaging is the column there of the data. Close the bracket, process the formula. So 538 is the mean value from those learners coming from feeder primary A. Now, I want to lock in the columns. I'm going to put the string sign in front of all of these columns. Won't change the formula. And I'm going to drag the formula across. And of course, the values will all be the same because I now need to change the A to a B, to a C, to a D, to an E, and finally to an F. So there we go. We have the mean values from learners sliced and diced by their feeder primary school. I guess there's something, the eye is drawn to the fact that feeder primary D seems to have significantly or a much higher mean value for those learners, and the opposite of that being that B and C have a much lower value of much lower mean value. Now, if we want to measure the significance of this, we can't use the t-test because the t-test only allows us to assess things that are split into two levels, like sex, boy, girl, or SEN, yes, no. And here we've got A to F different values. Yeah, we've got 6 different values. And there is a test for this in Excel. You can process information like this statistically, but it's not a t-test you need. You need something that's called analysis of variance. And it's not a built-in function to Excel. It's something you have to load via the add-in feature. And I guess Google that will show you how to do it. But via the add-ins section in Excel 2013, you have to go back to the home bit here and under options, and the option screen comes up under add-ins, Excel add-ins, and then you can load in the analysis tool pack. Now, once you've loaded in the analysis tool pack, under data, there will be a new option on the right-hand side that says data analysis. Okay, and one of the options in data analysis is Anova, analysis of variance, single factor, because the factor that we're looking at is the feeder primary school. Okay, so it's only a single factor. Granted, it's 6 versions of it, but it's only that factor that we're interested in. Now, we need to process the data here a little bit for us to be able to use analysis of variance. Okay, first thing I'm going to do is get rid of that mean calculation. And what I need to do is I need to organize the data in such a way as under each of these heading columns is the data for each feeder primary. I guess I'm now going to sort the data by feeder, and then I am going to copy the data for each feeder primary. I'm going to copy it from there to here. Okay, I'm going to make sure I paste it as a value. Make sure it's all lined up nicely. And I'm going to do the same for B. I'm going to copy it from here. I'm going to copy it from the data. I'm going to copy it, and I'm pasting it as a value because it exists as a formula. I'm going to do the same for C. Copy it over here, paste it as a value. Same for D, scroll down till I find D. So I'm doing the same for D, less learners in D. Same for D. And then I'm going to do the same for E. Do we have an F? Yeah, we do. We have a D, E, and an F. There's an E. Copying the data for E. There's the data for E. And finally, I'm going to copy the data for F, which is my catch-all primary. Not many in there. Copying those across into F. And I guess I'm just going to tidy this up a bit by make sure it's all centered, just so it looks a certain way. There we go. So now we've got column data for each of the feeder primary schools with the average point score underneath. And now we can issue the data analysis of variance Anova single factor function. So the first thing that this actually wants is looking for an input range for data. It's looking for where is the data that we're using. Okay, where is the data? And the data is everything that we've just carried across, including the column headings. Okay, including the column headings, the data that we've copied across. Because I'm going to tell it the data is in columns and the fact that labels are in the first row. And then I'm going to tell it to put my data, my output data, there. That's where the answer is going to be. The rest I'm going to leave the same. We've got an alpha value here, which is 0.05, which if you think back to our t-tests, is that value of significance. But we're not going to change anything. We're just going to click on OK. And quite a lot of output comes from the analysis of variance. But what we get is quite a useful summary of A to F in terms of the count, how many students, how many learners came from those schools, and some other information which I guess isn't relevant for what we're doing right now, but it shows us how many learners came from them. And then we have this thing down here which says source of variation, and this idea of between and within groups. Essentially what analysis of variance does is it compares the overall data, the variance, the variability of all of the data, compared to the variability within one group of data. Basically, we're looking to see if the ranges overlap from each individual school, okay? And the more they overlap, the less significant it is. If they didn't overlap at all, we'd have a totally significant answer. And what we get down here from the analysis of variance is a p-value. And that p-value is 0.11. So it's not significant. It's not the 0.05 value that we were referring to in the previous video, but it's 0.11. So we kind of want to get into this conversation about how significant things are. We're back up here, aren't we, where when we calculated the significance of sex, we had 0.2, and down here we've got a significance value of 0.1. So we could say that actually it's twice as significant which feeder primary school you go to compared to your sex. So if we were looking for, again, if we were looking for an initiative to improve our overall school results, we might want to consider working with our feeder primaries to see if there's anything particular going on in either a massively positive way. And if I look at my analysis of variance, my eye is drawn to school D that's got an average point score of the learners who went to that school of 613. And equally, my eyes are drawn to schools B and C with an average point score of about 462. I would wanting to be understanding why there is such a difference between those schools, okay? Because that difference overall for me as a secondary school is more important than the gender of my learners. However, all of that analysis wasn't particularly, well, it's quite easy, I suppose, but I guess if you were doing this per subject, if you were doing it for other multi-level factors, it actually becomes quite difficult to do in Excel. Excel really isn't designed for these significant statistical analysis. So there is another tool that we can use, and that tool you have to pay for, I guess. So if you don't have it, it won't help you. But that tool is, well, the tool I'm going to use is called Minitab. There's a number of statistical packages out there. So I'm going to copy all of my data, the worksheet of data that I've used. I'm going to copy it all, literally just to the clipboard, copy. And I'm going to go into Minitab, which looks a bit like Excel. This is Minitab 14. It's very old, it's 10 years old package. So I imagine you can get an updated version, and I think they do educator licenses. But in the very first cell here, I am going to paste all of that information I've just cut and pasted out from Excel. And it just looks like a worksheet, nothing hugely different. But Minitab is designed specifically to deal with this kind of statistical data. So in the first instance, if I do some basic statistics and I do a 2-sample t-test, and I say that my data, my sample data, is my total point score, and I break it down by sex, my subscripts are sex. I can do a t-test as before, so I'm breaking down the total point score by sex, click on OK, and up in the window here the data doesn't change. Up in the window is the analysis, and it says that my p-value is 0.217. I flick back into Excel. When I did this myself, my p-value was 0.217. Okay, just kind of confirming that everything is the same and the same data just displayed differently. So I could do the same for sex, SEN, and free school meal, but actually what we're interested in is the analysis of variance functions in Minitab. So I'm going to do statistics, Anova, and I'm doing a very simple one-way analysis of variance. My response is the total point score, and the factor is the feeder primary score. And I'm going to click on OK. What you get out of Minitab is some information here in the top window. I'll scroll back up so we can see it. So we get the same value here, 0.114, which is the same, or roughly the same as the value we had here, 0.114, the p-value. But we get a little bit more information. We get some indication of the confidence intervals, the spread of 95% of the data for each of the scores. So I can look at that quite visually, and it does appear that something interesting is happening to school D. Okay, granted there's only 15 learners, but actually the whole of their data set is shifted to higher grades. And I can say the same thing about B and C, that the whole of their data sets seem to be shifted to the left-hand side. So I could start to be having a discussion about what's different between these schools. Yeah, what is going on different to make such a difference in the outcomes at level 2 when we just look at the feeder primary. Now, as this is a statistics package, there's far more things that we can do. And one of the really interesting things, two of them, first of all, we're going to look at building what's called a general linear model. And a GLM, instead of thinking of feeder primary, sex, SEN, and free school meal, what if we think of them all at the same time? Yeah, stick it all into a melting pot and try and work out which of those things in total is the most important. So I'm going to do a general linear model, and my response is total point score as always, and my model is feeder primary, sex, SEN, and free school meal. Okay, going to do nothing more than that. It's literally saying, can I model my point score by taking those 4 things into account? And I'm going to click on OK. Whirs away, and you get a whole bunch of data on the screen here. So here's my general linear model. Just summarizing things, it's telling me the levels. So there are 6 different feeder primaries, and the other things are split into 2, boy, girl, yeses and nos. And then it does an analysis of variance, like we did before, but kind of across all of those input factors. And then we look at some p-values over here on the right-hand side. Remember, the lower the p-value, the more important the factor is. So for our level 2 outcomes, our total point score, the single most important factor in determining what that point score is whether or not our learner is on free school meals. Okay? The second most important factor is whether or not our learner is an SEN learner. The third most important factor is the feeder primary score. Yeah? Where they went to primary school has a long shadow in terms of their level 2 outcomes. And the least most important factor is the sex of our learner. So we start to consider that when we have whole school initiatives to do things and fix problems, that actually we have quite an interesting and powerful way to decide whether or not those things are important or not in the first place. Okay. There is something else interesting that we can do with a proper statistics package, and we're going to have a look at, if we consider on the right hand side here, what's called an interactions plot. So we're going to look at all the possible combinations of sex and free school meal. So boy and yes for free school meal, boy and no for free school meal, girl and yes, girl and no. We're also going to look at that for feeder primary. All the possible combinations of everything. It'd be quite a busy graph, but it'd be very insightful. We're going to say we're going to look at total point score, and we're going to bring in feeder primary, sex, SEN, and free school meal. And we get a chart that looks like that. Quite busy, but we'll start to decode it and see what's going on. We have here all the different symbols here in this row going across. The top row labelled feeder tell me which feeder primary school the learner came from. The next row down is the sex of the learner, male or female. The bottom one is whether or not it's an SEN learner or not. Okay. And then what we've got is almost like a cross tabulation of the two things. So in this box here, we've got feeder primary and sex. So we can see over here on the left-hand part of this plot, the data for all of the females from each feeder primary. And then on this side of the plot, we've got the data for the males from each feeder primary. And what we see is in most of them, actually, males perform less well than females, except in school D, the triangle here, school D. So school D, the males are doing much better than the females compared to all the other feeder primary schools. Now what we have in this one, we're looking at the feeder primary schools and SEN, and we see that actually in all feeder primary schools, learners classified as not on the SEN register have a higher performance than those classified as SEN. But interestingly, we start to kind of decode where some of this is going. We see that actually the impact is less, the gradient of the blue one, again for school D, is less than say for school E. So whatever's happening in E, the SEN learners who originally came from school E do much worse than the other schools. And we can break that down by free school meal, where we say no free school meals here, yes free school meals here, and we see the impact of going from one to the other. Not that by itself is similar to this. And then we have a cross tabulation of sex and SEN, where we see that actually female learners and male learners, if they're not on the SEN register, the performance is about the same. But if they are on the SEN register, the performance is lower in all cases, but we also start to see that the males, the red squares, actually perform worse than the females. So male SEN students do worse than female SEN students. Interesting thought to consider. And then in this box here, we have sex versus free school meal. We have the box here, the fact that male and female students, if they're not on free school meals, do about the same. But if they are on free school meals, we find the similar situation to sex is that free school meal students who are male do much worse than free school meal students who are female. So there's a cohort there, there's a group of learners, of boys who are on the free school meals list and boys who are on the SEN register do much worse than the females. And then we've got SEN against free school meals. So no free school meals if you don't receive free school meals, it actually makes quite a difference if you're on the SEN register. Yeah, the black circle being not on the register, the red square being on the register. But actually, if you receive free school meals, actually it wipes out the impact of being on the SEN. And actually, the most disadvantaged learners, as we would imagine, are those learners who are SEN and free school meals who are here. So this kind of picture, this interaction plot, allows us to start thinking about which of the things are the most important. And actually, are there groups of learners, or in this case, are there schools? School D here stands out as doing something different, their data is different. Or are there particular cohorts of learners or subgroups? In this case, it appears to be that the boys, boys on the SEN register and boys who receive free school meals seem to get kind of a double whammy of disadvantagedness, if that makes sense. So whilst Excel allows us to do a little bit of data analysis, and we can use t-tests and average ifs, and we can just about coax it to do analysis of variance. If we really want to think about the data in our school, we end up having to use a package, something like Minitab or SPSS, quite a few of them out there. They're not cheap, but I imagine within the school budget, if they don't exist already, if you really do want to drill into your data, these are the kind of tools that you need. So thank you.